Yeah, very excited to be here talking with real humans. That is my international flight since COVID. Um, this is Bryan. Coming from New Zealand. It's 24 flights, so I'm sure no one can beat me. But it's very exciting to actually speak with humans during a physical conference. That's something I really missing since the COVID days. Yeah, I'm the co-founder of Acala, as well as I'm also one of the contributors of Substrate and Polkadot. Some of you guys may know me as XLC. I've encountered those issues on Substrates, and maybe I can finally complain those problems with you face to face. Jokes aside, today I'm going to talk a bit more about how the future of DApp development, like how we compare Web 2 applications compared to Web 3 applications, and maybe we can draw some inspirations from this. We all know history always repeats itself. So sometimes if you want to predict the future, see if the price is going up or down, if things going in circles, you will look at historical data. And similarly applies for evaluations of the application development. Now we can, looking the past, see how the Web 2 application evolves and try to get some understandings of how they might be involved, how they applies to the Web 3 applications. So let's start with the infrastructure side. So that is basically where the applications are running on. So for simple Web 2 applications, that just means servers on the internet or just computers where the applications are running on. And then for Web 3 applications, then where we have blockchains, smart contract platforms, that things that you smart contracts or runtime application, etc., running on. So it all begins with this great innovation called computer. Well, I guess you all know it. So initially, we just have computer. You have applications. That's something like Excel, for example. They are super useful. You can do a lot of things with that. But with things on local computer, that is very limited. And then, on the pre-blockchain era, we have a bunch of cryptographic tools. You can do authentication, authorization, signing, encryption. They are super useful. They can achieve a lot of things. Simply cannot be done without those tools. But still, it's somewhat limited. There are a lot of things cannot be done with them. And then on the Web 2, we have more connections. We have computers, they can connect to each other. We have intranet and internet. And we can do a lot more interesting things. We can share things around the internet. We can, for example, hosting a blog with Web 2 servers. They are a lot more interesting, but I don't know how many you have actually host your own servers. I guess it's easy to have it up and running, but it's definitely not easy if you want to make sure it's secure, uptime, scale, etc., etc. So yeah, there's a lot of work required. It's not that flexible. And it's, again, can be expensive to build and operate and scale up. So looking at Web 3 sides, we have purpose-built blockchains, like blockchain built for only single purpose. That is just like Bitcoin is designed for transactions, payments. That is if you need something else, you need to build yourself. If you say, I don't know, you want to build a domain name register Web 3 applications, you need to build yourself. You might be able to fork Bitcoin, taking some powerful component from it, like P2P, for example. And you still need to build a risk. It's costly, it's very hard. A lot of people tried. Some get successful, some are not. And then, not everyone would like to operate their own server. Similarly, not everyone wants to, I don't know if anyone wants to operate their own blockchain. But that's one reason why we have clouds. But basically, someone else's computer, they manage the things for me. Like I can finally write my applications and then have a bunch of configurations, or also a credit card. And then I can have my application deployed on AWS in no time. It's pretty easy to build and deploy. They're super good and nice. And the cloud service provider, they just take care of a lot of work. So the developers, they don't need to worry about it. So similarly applies to the Web3 applications that we have smart contract platforms such as Ethereum. that people or developers or individual people, they can, using Solidity to write codes. And then, well, you don't need a credit card. You still need to have a bunch of ETH to pay the gas, but you can have them deployed in no time. That's super nice. You don't need to worry about transactions, formats, account formats, P2P protocols, et cetera, et cetera. So that's very good. And this is where most of the DApp applications they are right now. And then, if you're using any modern applications, they are mostly they are probably not purposely built to be multi-cloud, but they are. Like a lot of people saying building DeFi protocol is like building Lego pieces. Some protocol are just pieces, and some people assemble them in some interesting shapes, and then you have product. But we're already doing this for years on any modern SaaS applications. Like a lot of applications, they need features login, user support. Like then we can use in Google login, for example. We can use, I don't know, intercoms and DEX or something, service to take care of some individual parts of the user application flow. You don't actually need to build everything yourself. So that's good. You can focus on the business projects. You don't need to think about those. They can be delegated to other service providers. So people can build the applications much faster and much safer. And then if, say, you're using Google login, it will be dependent on, obviously, the parts will be running on GCP. Your own application might be running on AWS, and then some other servers might be, I don't know, running on Zora. But then those applications, they are basically multi-cloud applications. On the user's point of view, they don't care. They don't need to know. As long as those things are down, obviously, if AWS goes down, they will notice. But otherwise, assuming they're all secure and uptime is fine, then users are not going to know if there is a multi-chain application, or sorry, multi-cloud applications. Yes, so the underlying infrastructure should be transparent to the users. So similarly, well, on the other side, blockchain side, we start getting some network of blockchains. There are a bunch of different blockchains connect through bridges, and then we have the Polkadot ecosystem. Finally, the real connect blockchains without bridges by using the shared security and XCM. Very excited for the actually go live in the next few weeks. But anyway, we can have this kind of things that applications, they can depending on other servers. So this is just an example applications. We don't really have this thing yet. Well, we'll help take this idea and build it, please. So say we have a lending applications in the middle. It can using assets, AUSD, LDOT, liquid staking DOT from Acala. You can using DOT from Polkadot. They can be using like USDT, for example, from StateMine. They are all just assets that the application shouldn't, that the use of the application, they should see, I don't know, 50 USDT, 50 DOTs, 50 AUSD, setting on different blockchain, but there's the money. Why do they need to know which blockchain the money is setting on? So users will see the balance, I guess, and then underlying the lending app, it could be deployed on Acala or some other EVM platforms, so all the EVM platforms. Like you can, in modern applications, you can have them deployed in different clouds or all the clouds if you want to. Like this should similar can happen on decentralized applications. It can be deployed on different EVMs. And then because we can communicate with each other, there's a lot of things that can be done. If as a lending app, you probably need to allocate the tokens or the liquidities across different instances of the deployment based on the needs or requirements to rebalance them. Well, that's fine. There are a lot of easy ways to do that. With XCM, things can happen trustlessly without any troubles. And then, then most of the decentralized protocols or DAO, they will probably have governance features. Then most of them will need some identity providers. So people, when voting, say, a proposal, you actually know who proposed this proposal, which is quite important. And then, we can potentially using identity service provider like Cloud. So as the application developer, we'll be able to access all these things, deploy here, but I don't need to worry a lot about the things. I don't need to build my own identity solutions. Why should anyone want to? People shouldn't need to do that. And then this application should be natively or built inherently multi-chain, so to provide a real, true user experience to the users. So this is something I really would love to see to be happened in, well, it could be one of the hackathon thing. Now look on the other side. So infrastructure is where the application runs on, and then how the development paradigm is how we build applications. So again, I was iOS developer, so I was just using that as an example. Initially, to build an iOS app, you need to use Objective-C, which is a great language. But still, well, you kind of need to do all the work yourself. And then if you do happen to need Android applications, you can't really use the iOS code there. You just, most of the time, need to rebuild most of them from scratch, which is a lot of work. Yeah, on the Bitcoin as well, is, well, again, single purpose build from ground up using C++. There's a lot of work. Yeah, it's just not easy to build a native application. Well, that was the old times, but now we own, like if you're a mobile developer, you know there's a lot of library frameworks to make things easier. And now we have Substrate, so actually building another Bitcoin is quite easy. So this is kind of a solved problem, which is great, but let's continue. And then we have, to solve this cross-chain platform issues, people have created a thing called hybrid app. So it's using a framework like, for example, Ionic. So basically, we package, the application itself we written using HTML and JavaScript, and then the application will be packaged in some binaries can be deployed on iOS or Android. The application logic is shared using the same code. That's great, but you don't need to actually write things in twice, because why would anyone want to do that? You can come with easy multi-platform support, but everything else is a trade-offs. There are some considerations about using this approach. The first is that the performance is not that good. It was very easy to tell if the app is built with Ionic because, well, you can feel the scoring is not smooth animation, it's laggy. So it's not the best user experience you can provide. But, well, it's fast and it saves time. But if you're building anything more advanced, you want to leverage all the features of the hardware, I don't know, using GPS, using camera, you need to fall back to using the native APIs, which can be done using Ionic app. But now, talking on the other side, the Web3, we are now mostly people using Ethereum Solidity EVM to build applications. We have the Solidity code, run, compile, deployed. It runs on Ethereum. Just a matter of some configuration changes. The same thing deploys on the new EVM blockchain, which is great. But again, same issue as Pies. There's inherently going to be some limitation on the performance of EVM. EVM itself is also not really designed to be the most performant VMs. That a lot of decisions is just not designed for speed. And then if you need to use some of features that is not exposed to you by the Ethereum EVM sandbox, well, it's tough that you can't really build your own native plugins. You can propose EIP, try to get them implemented. I never tried myself. I don't know if any of you have tried it, but I'm not going to depend my next moon landing projects on that. So that is very limits what can be achieved with using this approach. And then a lot of apps now, they are building things like React Native, which is, basically the idea of React Native is that you learn once, you can write multiple, all the places. You learn React kind of concept. You don't necessarily porting the existing code directly to other platforms, but the concept is that you can easily rewrite them. So using this kind of approach, we can still building applications using the higher level language, such as JavaScript, TypeScript. This is much easier for most of developers to use. But we can easily fall back to using a native code for any resource-intensive work, such as that handling animation, for example. That is one of the good things about it. It can be done very efficiently. So it's sharing most of the benefits of the hybrid apps, but it can be much, much faster. And it's also designed in such a way it's easier to access the native features. And on the Web3 side, I don't think we have the hybrid, this kind of thing running. I guess so it's totally possible with Substrate and EVM things, we should be able to doing something similar. We should be able to have the applications running using Solidity again, or some other higher level language, not Rust, because well, Rust is great, but I know it's definitely not the most used of beginner-friendly language. So people should be able to write language use Solidity, have them deployed. If they need some native features, actually having the blockchain supports them. Blockchain actually provide APIs for them designed to be integrated with with the Solidity languages. So you can have the applications to be both on the runtime, on the smart contract side and the runtime side, working together. Then you can have some of the compute-intensive tasks building using in Substrate parlors. You can have some of the things, I don't know, like governance, things that parameter changes, things that, or if you, I don't know, building some strategies that changes every once in a while, that can be happens in the smart contract side. So you're really getting the benefits of both sides by using this kind of approach. So that is not a hypothetical application. That is actually something running inside Acala. So well, it's actually running right now on your Kurura, but will be live on Acala. So this Tapio protocol is a stable sort protocol. So it have built a stable sort palette that's embedded inside Acala runtime. That handles the calculations, the actual swap, a lot of things. It's just much easier to write using Rust compared to Solidity, doing all the math, basically. And then the EVM side is able to access this palette through some special precompiles with authors. So the contracts can call into the palettes directly, and the palettes can also call into the contracts directly through some APIs. In the workshop I'm going to give on Saturday, I'm going to explain that. And then the palace is able to access the native access, AUSD, for example, as well as the EVM ERC20 access. That will be, say, USDC bridged to Acala through one whole bridge. There will be a wrapped ERC20 tokens. So this comes with a unified interface, so the palace can work with both of them without worrying about the low-level detail. If it's a native token, it's a substrate token. If it's ERC20 token, it doesn't matter. The palace can simply access them without any problem. And then the contract is also able to, only from EVM side, this is another ERC20, so obviously that works. And all the native tokens, they are also exposed to the EVM as ERC20 tokens. So to use the native assets from Acala, it's just another ERC20, it just works. So with this new architecture, there come a lot of benefits. The runtime obviously is much more performant. The stable asset palette is built by the Tapio team, maintained by them. So if they, well, obviously they still probably want to work with us to make sure it secure, safe, doesn't come with some loopholes causing some troubles. But again, it's up to them to design an interface, what sort of feature they want to expose to the smart contract side. They are the guys building both the application on the runtime side and the smart contract side. They are like the guys designing APIs. So they don't really need to go with a long EIP process. Hey, I would like to make sure the precompiles look exactly like that. They just do it themselves. And of course, after the code is secure and safe and reviewed by us, it can be merged and upgraded. And then on the EVM side, well, it's just smart contracts. So all the same, say, upgrade proxy patterns applies. If they want to do a governance there, however governance process they want, they can implement it. And whatever process pass, they have the governance contract upgraded, parameter adjusted, things changed, so that they can handle all these things without, say, if they want to adjust some, I don't know, the fees or something, they don't need to go to Acala governance process, which is that why should the application upgrades need to go with the blockchain layer 1 of governance process. So with this approach, we can have a quite clear separations on this. So yes, I believe this will be one of the ways that we could build. Of course, not all applications should be built with this way, but it definitely provides a very interesting possibilities on how we can build those things. And of course, there are always challenges. I look at how much GitHub issues I've raised. There's always a lot of things we need to do. So first thing is about more of multi-chain applications. If everything runs in a single server, you can just call the process, call this function, and just do some blocking and return, just like on Ethereum, start iterating between different smart contracts, super easy and nice, and everyone's happy with that. Except it doesn't scale. If we only want to scale it, do things on multiple blockchains, the communication and message passing, they are not synchronized, they are asynchronized. So that creates a lot of challenges, which we already faced them before, and they are already solved. We just need to do the thing again. That if you want to build a Node.js server calling another server, you will all know if you if there was a lot of risk condition can happen if you not try to manage the state properly. This was callback health. If you write JS ES5, you will know how bad that was. There, of course, can introduce a lot of unexpected dependencies on how the orders of things that could change your dependency on the server returns things faster than that, then suddenly this have some lag and things doesn't work. So it can be very challenging, but again, we already have solved all these problems. There's no reason we cannot solve it again. But of course, there's a lot of pain which happened. I don't know how many years it took JS involving from callback hell to actually to asynchronize ES6 and finally solve. So similar thing is needs to be happened. And then for the UX side, that is, if you only deal with EVM chains, I guess you probably find you only use MetaMask. Still, that is a hassle. You need to remember switch your networks and doing things. If otherwise, unexpected things could happen. And the assets and protocols are everywhere. And again, that is something that users shouldn't need to know. Why they need to know which assets my tokens are. And users should be choosing the applications, not choosing the blockchains. No one uses your application because it's deployed on Azure or because it's deployed on AWS. They use application because it's a great application, not where the application are deployed on. Of course, it also depending. The assumption is that all these low-level platforms that are similarly secure and safe, well, which is not the case in other side, but at least on the Polkadot side, we have shared security, so I guess that's all the same. Yeah, then there's always, well, again, we're making trade-offs. There's always, you can make things secure, they will be slow. You can make things very flexible, and then they will be insecure. There's just a lot of decisions, or writing software, building software is basically making decisions all the time. So we are, well, good at that, and we have done that before. There's no reason we cannot do this again. It's just a lot of hard work is still required. So we're still very early stage. So that's one reason why we, and all the project teams, all the teams here, they have bounties listing all the challenges we have, hoping you guys can helping us to fix them. Yeah, right now, most of the applications, they are focusing, or most of the protocols they're focusing on single blockchains. On previously, that's fine. We know everyone either uses Ethereum or use BSC. They don't really using them at the same time, I guess. But now with the Polkadot ecosystem, we are inherently a multi-blockchain thing. So yeah, the protocol really should be designed to be works with multi-blockchain to leverage those benefits. I guess you can still choose to not do so. You will be building another existing Ethereum app, which is totally fine, but will be less interesting, I guess. Yeah, again, you can make your applications hybrid to taking the benefits of both sides. You can, the flexibility of the smart contracts and the performance and all the unique features like, I don't know, option workers, prioritized transitions, operational transitions, they are just simply impossible with Solidity. now can be possible using this hybrid app approach. You can take in full leverage of the substrate features without actually coding all of everything inside substrate. And again, kind of repeating myself, but the UI should be focusing on the assets, that people should know what are the assets. They shouldn't, why should they care about the infrastructure? And we have done this before. I think we should take a look back at how this have happened on the Web2 application development, see if we can draw any inspirations from there, that there are a lot of good lessons we've learned there that can be applied here. Of course, we still probably need to reinvent some of whales. That's perfectly fine. We just need to, make sure we're not making the same mistakes again. And again, we still need to do a lot of investment and improve the infrastructure side. That's again with one of the reasons we have all these bounties, and Polkadot Treasury is also helping a lot on this area. So now you know how maybe you can some good ideas. There are a lot of ways to build with Acala. So again, we're going to launch our EVM Plus very soon, and you can deploy your Solidity smart contract projects there, or you can deploy your pilots, or you can deploy elsewhere, but still, because we are connected application, we are connected blockchains, you can still be part of Acala ecosystem without actually be deployed on Acala, because we can still communicate, work together on solving some problems. Or you can just choose authority that works fine. So yeah, it's up to you. Think about it, see if you can find any edges or alphas, I guess, if you can go with some approach, doing something interesting that was simply not possible before. A lot of people asking me when EVM. So I would like to say, it's going to we're going to do a phased release. And the first phase starts next week. It will be this week if I'm not here, but probably I don't really want to get things out of the door while I'm staying on stage and then my phone ran up where I want to file. So it will be happening next week. So it will be a phased approach. It starts with the one-hop bridge. So one-hop bridge will be deployed as smart contracts, Solidity smart contracts, and then it will be deployed on the Kurura first. And then the second phase, we want to go with a phased approach because we don't really want to everyone start deploying the assets, and we are not 100% Ethereum compatible. There will be some troubles. There will be some technical difficulties. We are still a small-ish team. We cannot handle all the support requests at the same time. So we're going to do a phased approach, letting some people in first while we're taking the feedbacks, improving our documentations, work with them, and then letting more people in. So then first thing, one-hop bridge. Second thing, there will be a lot more dApps already working with us for a long time. And then after things are we're very comfortable, everything are running, all the software are tested, nothing goes wrong, then we'll be open to everyone. So again, everything will be happening on Kurura first, and for Acala followed by that. So every phase usually 2 to 3 weeks after the Kurura release. So the whole reason of Kurura is they will try things there. If it's good, we deploy it on Acala. So so it will be like the first next way, and then after 3 weeks will be the private release, not like go through this way. It's more going parallel. So really looking forward to see you guys, some of you guys having your application deploying the Kurura and Acala. So yeah, let's build together. Thanks.